back to Lahari Codes. In the previous classes, we learned different types of loops like for loop, while loop and do while loop. And we also solved basic problems. Today we are solving important placement level loop problems with complete dry run and logic understanding so that you can confidently answer in interviews. So let's start our class. I will explain everything step by step including logic and dry run. So let's see problem 1, LCM of two numbers. We take two numbers 4 and 6. So int a equals to 4 and b is equals to 6. And we first find the maximum of these two numbers. Int max is equals to a greater than b in brackets and question mark a colon b semicolon. And so max becomes 6. Now we start a while loop with condition 2. This means the loop will run continuously until we stop it manually. And inside the loop we check one condition. If max is divisible by both 4 and 6, it prints LCM and stop the loop using break. If not, we increase max by 1 and check again. So see here with max plus we increase. And now see step by step. See the box here, step by step execution. You can understand clearly. Coming to step 1, maximum is 6. 6 modulus 4 is 2 is the remainder. And 6 modulus 6 is 0. And both the values should come 0 to become valid. So it is not valid. Coming to step 2, 7 is the maximum. 7 modulus 4 is 3 and 7 modulus 6 is 1. Not valid. Coming to step 3, 8 is the maximum and 8 modulus 4 0. 8 modulus 6 is 2. Not valid. Coming to step 4, 9 is the maximum. 9 modulus 4 is 1 and 9 modulus 6 is 3. Not valid. Fifth step, 10 is the maximum. 10 modulus 4 2 and 10 modulus 6 is 4. Not valid. Coming to sixth step, level is the maximum. Level modulus 4 is 3 and level modulus 6 is 5. Not valid. Coming to step 7, 12. 12 modulus 4 is 0 and 12 modulus 6 is 0. So LCM is found. Both the reminders are 0. And here we use a while loop. Inside the loop we check is the number divisible by both 4 and 6. If divisible, that is our LCM and we stop using break. LCM equals to 12. So this is the output. And this type of problem is commonly asked in interviews to test the loop logic. So this is about LCM of two numbers. Coming to problem 2, sum of even and odd numbers. Now we take two variables, even sum equals to 0 and odd sum equals to 0. And we run a for loop from 1 to 10. Int I equals to 1 and I less than equals to 10. And inside the loop we check if the number is divisible by 2, it is even. So we add it to even sum. Otherwise we add it to odd sum. So let's see step by step execution. First I1 goes to odd sum. 1 is odd. So we add it to odd sum. Coming to 2 is even and we add it to even sum. And coming to 3 is odd. So we add it to odd sum. And 4 is even. We add it to even sum. So it goes on like that 5, 6, 7, 8, 9, 10. And final answer is even sum is 30 and odd sum is 25. Of even and odd numbers. And this type of problem is commonly asked in interviews to test the loop logic. So here the logic is if it is divisible by 2 even and add it to even sum, else add it to odd sum. So coming to problem 3, perfect square. Int num equals to 25. Now we take number 25 and we assume initially it is not a perfect square. Boolean is square is equals to false. And we run a loop from I equals to 1. We check I multiplied by I equals number or not. So see here for int I equals to 1, I into I less than equals to number I plus plus. If I into I equals to num, if square true, break, and if is square, system.out.println perfect square. Else system.out.println not perfect square. So let us understand step by step execution. First 1 into 1 is equals to 1, not equal. 2 into 2, 4, not equal. 3 into 3, 9, not equal. 4 into 4, 16, not equal. 5 into 5 equals to 25, match font. So 25 is a perfect square. So this type of problem is commonly asked in interviews and the output is perfect square. We found 25 match font, so it is a perfect square. This is about problem 3. Coming to problem 4, power of number. We take base equals to 2 and exponent equals to 3. So we initialize result equals to 1. So here see int base equals to 2 and exponent equals to 3, int result equals to 1. And we run loop 3 times. For int I equals to 1, I less than equals to exponent means 3. So result is multiplied. Each time we multiply result with base. So see the step-by-step execution. First iteration result becomes 2, second iteration result becomes 4, and third iteration result becomes 8. So final answer is 8. So see the problem here, and this type of problem is commonly asked in interviews. To test the loop logic, we multiply result with base each time. So the final output is 8. Let's see problem number 5, number pattern. So we will print a number pattern using nested loops in Java. See the pattern here. Let's look at it. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. So see the logic, observe it carefully. Row 1 prints 1 number and row 2 prints 2 number, row 3 prints 3 number and row 4 prints 4 number. So number always starts from 1 and go up to the current row number. So see the code. For int I equals to 1, I less than equals to 4, I plus plus. And for int j equals to 1, j less than equals to I, j plus plus. So here I represents the row number and j is used to print numbers. Outer loop runs from 1 to 4, controls rows, and inner loop runs from 1 to I and prints number in each row. After printing each row, we move to the next line. So see here, when I equals to 1 prints 1, and when I equals to 2 prints 1, 2, and when I equals to 3 prints 1, 2, 3, and when I equals to 4 prints 1, 2, 4. So see the final output. And this outer loop controls rows and inner loop prints numbers from 1 to the current row number. So that's how we print a number pattern using nested loop. Coming to problem 6, largest digit. So see here, we take example as number as 5832. So int num equals to 5832 and int max is equals to 0. While num not equals to 0, int digit is equals to num modulus 10. If digit greater than max, max is equals to digit, num is equals to num by 10. So system.out.println largest digit. So see a step-by-step logic. We initialize max is equals to 0 and we run a while loop until the number becomes 0. Inside the loop, extract the last digit using num modulus 10. Compare it with max. If the digit is greater, update max. Remove the last digit using num is equals to num by 10. So see the table and step-by-step execution. First iteration, digit equals to 2, maximum 2. And in second iteration, digit is equals to 3, max 3. Third iteration, digit is equals to 8, max is equals to 8. And in fourth iteration, digit is equals to 5, maximum remains 8. So the final output is largest digit 8. So we extract each digit using modulus, compare it with maximum and update maximum to find the largest digit. That's how we find the largest digit in a number using a loop. Coming to problem 7, string check. So here what we will do means we check whether a string contains both letters and digits. So we take the string ABC123 as an example. First we initialize two variables, digits equals 0 and letters equals 0. Now we use a loop to go through each character of the string one by one. Inside the loop, we take each character and check its type. If the character is a digit, we increase the digit count. And if the character is a letter, we increase the letter count. Now let's see step-by-step execution. First character is A, it is a letter. So letter becomes 1. And next character is B, it is a letter. So letter becomes 2. And next character is C, it is a letter. So letter becomes 3. And next character is 1, it is a digit. So digit becomes 1. And next character is 2, it is a digit. So digit becomes 2. And next character is 3, it is a digit. And so digit becomes 3. Now all characters are processed. After the loop, we check the condition. If digit is greater than 0 and letter is greater than 0, then we print strong pattern. Otherwise, we print weak pattern. So in this example, both digits and letters are present. So the output is strong pattern. This type of problem is commonly asked in interviews to test strings handling and character checking logic. In simple words, if a string contains both letters and numbers, we call it as a strong pattern. So today we solved important loop problems with full step-by-step logic and dry run. And if you practice these problems, you will become strong in programming logics and interviews. Thank you. And if you found this helpful, please like, share and subscribe Lahari Codes.